Hello learners, welcome to our today's mathematics learning session. Today we'll be introducing a new unit known as statistics. Statistics. So learners, I want you to write down statistics. Statistics. And in this unit, you're going to have the following unit objectives. Unit objectives. Unit objectives. By the end of this unit, by the end of this unit, the learner should be able to, one, by the end of this unit, we are calling statistics. You as the learner should be able to, number one, define the term statistics. Define statistics. Should be able to define statistics. Then number two, you should be able to draw frequency distribution table. Frequency distribution table, and we'll be learning how to draw frequency distribution table for ungrouped data and also grouped data. Then number three, the third objective, the learner should be able to calculate the measures of central tendency. Measures of central tendency. Measures of central tendency, that is the mean, the mode, and the median for both ungrouped data and grouped data. For ungrouped data and grouped data. Then number four, you should be able to group, the learner should be able to group data into, reasonable classes. Reasonable classes, grouping data into reasonable classes. Then number five, the learner should be able to represent data in form of line graphs, bar graphs, pie charts, pictograms, histograms, and frequency polygons and frequency polygons. Represent data in form of line graphs, bar graphs, pie charts, pictograms, histograms, and frequency polygons. Then lastly, you should be able to interpret data, interpret data from real life situations. Interpret data from real life situations. So learners, this will be our unit objectives. By the end of the unit we are calling statistics, should be able to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is what we are setting out from today onwards until we'll come to interpreting data from real life situations. This will be our last lesson. We'll learn how to interpret data from real life situations. Real life situations. Interpret data from real life situations. So learners, in our today's lesson we are going to concentrate on the first two objectives. First two objectives. We learn the same way we eat. When you are eating, if you have a full plate of ugali, you don't swallow the whole of it at the same time. You cut it into small pieces, then you chew bit by bit. The same way here, we cannot cover all this today. We'll have to pick bits. So in our today's lesson, we are picking the bit on definition of statistics. Then we'll also learn how to draw frequency distribution table for ungrouped data. So learners, I hope you are ready to learn with your book. You have a book, you have a pen, and you are in an environment where there are no disruption. When you are studying mathematics, make sure the environment is conducive to learn. Switch off the television, all right? Have your headphones on, and then concentrate on learning. So let's now start by defining statistics. Statistics. Definition of the term statistics. What is statistics? Learners, statistics is a branch of mathematics. Is a branch of mathematics that deals with collection, organization, representation, and interpretation of data. Is a branch of mathematics that deals with collection, organization, representation, and interpretation of data. That's why in our objectives, you saw that our last objective will be in regard to interpretation of data from real life situations. Okay. Now, what is data? What is data? Data is is basic information. Information usually in numerical form, usually in number form, is basic. It is raw information. Basic information usually in number form. For example, you can one may take data or information in relation to the number of shoes, the shoe size of students in a classroom. You may decide also to take data in relation to the masses in kilograms of students in a classroom. You can also have another example data as the height to the nearest centimeter of the students in a class. Data can also be the marks obtained in a recent test. Data can be the number of children in families. You can put together the number of children in families. Then data can also be in relation to the favorite subjects of students in a class, the favorite games of students in a class, the time taken in 100 meters race by students in a class, the daily temperature recorded, Data can be the number of invoices in a month, Data can be the number of kilograms of bags consumed in a hotel in 1 year, and so on and so forth. So those are examples of data. We said data is a basic information usually in number form, and we have defined statistics as a subject that deals with collection, organization, representation, and interpretation of data. So learners, that is the definition for the term statistics. Now let's move on to our another section in this class, which is frequency distribution table. Frequency distribution table. Frequency distribution table. Frequency distribution table. And this is a simple table that shows data items and the number of times they occur in a set of data. So before we do the table, I want us to have this example. The following data represents number of shoe sizes worn by 20 students. The following, you can write this down. The following data represents the shoe sizes. The shoe sizes worn by students. The shoe sizes worn by students. So there is the first students worn by 20 students. These students are 20 students. So the first one, number 7, number 9, number 6, number 10, number 8, another one 8, another one 1, 9, 11, 8, 7, 6, 8, 7, 9, 8, 7, 9, 6, 8, 10, 8, 10, 9, 8, 9, 8, 7, 7, 8, 9, 8, 9. So we have 7, 9, 6, 10, 8, 8, 9, 11, 8, 9, 11, 8, 7, 9, 6, 7, 9, 6, 8, 10, 9, 8, 7, 7, 8, 9. So these are the sizes. So we can represent this data in a frequency distribution table. Represent this data in a frequency distribution table. Frequency distribution table. So answer frequency distribution table. Frequency distribution table. So these are shows the data represent the shoe sizes. So the first column will have shoe size, then the next column will have the tally, then last we will have the frequency. So we have the table right there: shoe size, the tally, and the frequency. Shoe size. Okay, have that table, learners, in your books. Have that table. So we start by listing the shoe sizes. We have 7, 6, 9, 10. So the least shoe size from this data is 6, followed by 7. Then you have shoe size number 8, shoe size number 9. Do we have 10? Yes, we have 10. How about 11? 11. 12? No, do have 12. So we need to tally. Learners, we need to tally. Next step is to do the tallying. Number 6, how many times does 6 appear or occur in this data? How many times does 6 occur in this data? How many times does the shoe size number 6 appear or occur in this data? So we are going to use strokes. Okay, so stroke 1, 2, only 2. So these 2 strokes represent one tally. One stroke is one tally, another stroke, another tally. So we use strokes. Each stroke representing a tally. Each stroke representing a tally or a quantity. How about 7? 7, you have 1, 2, 3, 4. So these are 4 strokes. So we come here and show the strokes: 1, 2, 3, 4. 4 strokes. Number 8, shoe size number 8. Number 8, you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we'll come here and indicate the strokes. 1, 2, 3, 4, 5 and 6. 5 plus 1 is equal to 6. Shoe size number 9 was worn by how many students? 1 student, 2 students, 3 students, 3 strokes. 1, 2, 3. 3 what? 3 strokes. Number 9, number 10, number 10, number 10, 1 student, 2 students, 2 strokes. Number 11, how many students? Number 9, are they 3? Number 9, I can see this one is hanging. You have 1, 2, this is also hanging. So number 9, you have 1, 2, 3, 4, 5. So number 9, we have 5 strokes, 5 quantities, 5. That's number 9. And the good thing about showing the strokes here, you can know which one you have missed out, like the other one I had missed out. Then number 10, we had only 1. 10, we have 1 and 2 strokes. 11, 1. 11 was the highest shoe size, worn by only 1 student. 1 student. So these are the tallies. Each tally represents a quantity. Each tally representing a quantity. Then we come and count the strokes, which we've said represent quantities. So frequencies. 1, 2, we write here 2. 1, 2, 3, 4, we write 4. 1, 2, 3, 4, 5, 6, we write 6. 1, 2, 3, 4, 5, we write 5. 1, 2, we write 2. 1, we write 1. So this should give us 20, because there are how many students? 20 students. So we have 2 plus 2 is equal to 6, plus 6 is equal to 12, plus 5, 17, plus 2, 19, 19 plus 1, 20 students. 20 students. So we have represented this data in a frequency distribution table. Frequency distribution table, and you can see this data is not grouped. That is ungrouped data. Ungrouped data. So learners, that is example number 1. Example number 1. Example number 1. So we just said frequency table can be used to represent data. The question was represent this data in a frequency distribution table. We have defined a tally as a stroke which represents a quantity, and frequency is the number of times an item or value occurs. Frequency is the number of time a value or quantity occurs, or an item occurs, the number of time an item occurs. This shoe size number 6 occurs 2 times. Number 7 is occurring here 4 times. So 4 is a frequency. 8 occurs 6 times. 6 students wear shoe size number 8. So this 6 is frequency, number of times a value or an item occurs. That is frequency. Frequency. So I want you to write that down, learners. A tally. This is a stroke which represents a quantity. A tally is a stroke, like this one here is a tally, is a stroke, and it represents a quantity, one quantity. In this case, this one represents only 1 student. Then frequency, this is the number of times an item or value occurs in a set of data. Number of times. For example, this 6. The number of times an item occurs in a set of data. This 6 is a frequency. 6 appears, this 8 appears 6 times. So this 6 is the frequency. Frequency of 8 is 6. Frequency of 10 is 5. Frequency of 11 is 1. That means 11 only occurs once. So this 1 is the frequency. So then, learners, let's do another example. The data below shows marks obtained by 20 students. Following data, let me write it here. Let me write this here. The following data shows marks obtained. The following data shows marks obtained by 20 students. 20 students. 9, 5, 5, 4, 5, 3, 4, 5, 4, 5, 3, 5, 11, 6, 5, 11, 6, 5, 11, 6, 3, 6, 8, 3, 6, 8, 3, 6, 8, 9, 6, 13, 9, 6, 13, 8, 8, 13, 5, 10. Prepare a frequency distribution table. Prepare a frequency distribution table. So this is the table. So we'll have the same format. The format is the same. The data is not the same. So the format is the same, but here we have marks, student marks, student marks, students marks. So we start by showing the least mark. We arrange these marks. We start by the least mark, and the least mark here is 3. So we write 3. Then we have 4. Yes, we write 4 is the next. Then we have 5. We have 6. Yes, 6 marks. 7 marks. 7 marks. Any student who scored 7 marks? No. But we have 8 marks. 8 marks. 9 marks. 9 marks. 10 marks. Do you have 11? Yes, 11 marks. 11 marks. 12 marks. No. Then we have 13 marks. Okay, 13 marks. So let us tally. How many students scored 3 marks? So we come to the original data and use strokes 1, 2, only 2. So these are 2 tallies, 1, 2. Then 4 marks, 4 marks, 1, 4 marks. Only one student scored 1 mark, scored 4 marks, 1 tally. 5 marks, 1, 2, 3, 4, 5. 5 students scored 5 marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How about 6? 6 marks. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3 students scored 6 marks. 8 marks. 8 marks. 8 marks. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Students scored 8 marks. 9 marks. How many students? 1, 2. 1, 2. 1, 2. How about 10 marks? How many students scored 10 marks? 10 marks. 10 marks. 1. 1. 11 marks. 11 marks. 1 only. Only 1 student scored 11 marks. 1. How about 13? 13 marks. 13 marks. 13 marks. 1. 13 marks. 2. 2 students scored 13 marks. So 1, 2. So we have tallied. We have tallied. So we now count the tallies. Count the strokes. 1, 2, we write under frequency 2. 1, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. 1, 1. 1, 1. 2, 2. So we have done the tallying. We have inserted the number of times, that is the frequency. Then we add, and this should give us 20 because there are 20 students. So 2 plus 2, 3 plus 5, 8 plus 3, 11 plus 3, 14, 14 plus 2, 14 plus 2, 16, 16 plus 1, 17 plus 1, 18 plus 2, 20. 20, and this is correct. So we have done 2 examples, learners, in the preparation of frequency distribution table, and that will mark the end of our today's lesson, where we introduce the topic statistics. And in our today's lesson, we have managed to do 2 things. Number 1, define statistics and prepare the frequency distribution table. Frequency distribution table. We said that statistics is a branch of mathematics that deals with the collection, organization, representation, and interpretation of data. So we have gone ahead and represented data in a frequency distribution table using 2 examples. Learners, it's your time now to practice. So this will be your assignment. Today's assignment is taken from the pupil's book. Assignment. Exercise 18 point. This is 18.1. 18.1. This assignment from your book. 18.1. Go and do question 2A, question 2A, question 3, question 4A, question 5, question 6A. This is only frequency distribution table. You will only do the frequency distribution table. Question 6A. Then we have question 8. Question 8. This will be your assignment. Make sure, learners, the assignment is done before you come to our next lesson, where we continue studying more about statistics. Thank you for attending this lesson. Thank you for being attentive. Thank you for writing the notes. And I want to thank you in advance for doing the assignment. We said in mathematics, unless you do the assignment, you may not be able to grasp some of the concepts that we are teaching at Manifested e-learning forum. Bye-bye.